Hi, this is Alex from devstories.eu, Async IO, episode 5 of 20. Before Python 3.11, firing off multiple concurrent tasks was easy, but handling them safely when one crashed was notoriously difficult. You would often end up with orphaned background tasks quietly wasting resources. The solution to this mess is structured concurrency using TaskGroup. A task group is an asynchronous context manager. People sometimes confuse it with a standard list of tasks, but it is much stricter. It provides strong safety guarantees about how tasks begin and end. It enforces a rule that a parent routine cannot finish until all its child operations are either complete or cleanly canceled. You use it by opening an async with block. Inside that block, you call the create task method directly on the group object to start your concurrent operations. You do not dump these tasks into a standard array and await them manually. Instead, when the code reaches the end of the async with block, the task group implicitly pauses. It waits right there until every spawned task finishes. The block simply will not exit early. Here is the key insight. The real power of a task group lies in how it handles failure. With legacy tools like Gather, if you started several tasks and one threw an error, the others kept running in the background. You had to write complex error handling logic to track down the survivors and kill them. A task group handles this automatically. Take the scenario of a web scraper fetching 3 distinct API endpoints simultaneously. You need user data, recent posts, and system alerts. You open a task group and spawn 3 tasks. They all start running concurrently over the network. Halfway through the operation, the recent posts endpoint times out and raises a connection error. The task group immediately detects this failure. It intercepts the error and automatically sends a cancellation signal to the user data task and the system alerts task. It cleans up those pending operations so they do not continue eating network bandwidth or memory. The remaining tasks raise a canceled error internally, acknowledging the shutdown. Once all the remaining tasks are safely stopped, the task group bundles the original connection error into a new structure called an exception group and raises it out of the context block. This behavior makes your asynchronous code entirely predictable. If execution moves past the block successfully, you know for a fact that every single task succeeded. If the block raises an exception group, you know that the failure was caught and everything else was properly shut down. You never leave rogue tasks running in the background. If you need the results of the successful tasks, you can retrieve them directly from the task objects you created, provided they completed before the failure occurred. By binding tasks to a strict lifecycle block, task groups guarantee that concurrent operations enter and exit your application as a single coordinated unit. That's it for today. Thanks for listening. Go build something cool.